It's so funny.
We've made it to page 4 now in our final review. First inequality on our sheet, we have lots of fractions, so I'm going to multiply the whole thing by the common denominator of 6. 6 divided by 6 is 1. 1 times my numerator gives me 5x plus 3 minus 6 divided by 2 is 3. 3 times my numerator, would be written like that, is less than or equal to, on this side, 6 divided by 3 is 2 times the numerator. Getting rid of all my parentheses, I'm going to have 5x plus 3 minus 21 minus 9x is less than or equal to negative 8x plus 18. Putting my like terms together gives me negative 4x minus 18 is less than or equal to negative 8x plus 18. Let's move the negative 8x to this side and the negative 18 to this side. When I do that, add 8x to both sides, I'm going to move over here. I get 4x is less than or equal to 36. Simplifying, I get x is less than or equal to 9. On the second problem we have here, we have the sum of 3 consecutive even integers is equal to 312. Well, if my first integer is x and it's even, then the next even would be x plus 2, and the next one after that would be x plus 4, because evens are 2 apart, like 2, 4, 6. If we find the sum of those, we're going to get 3x plus 6 is equal to 312. Solving this gives me 3x equals 306, so x must be 102. X plus 2 would be 104, and x plus 4 would be 106. For question number 3, I believe this might be a little different on your worksheet than mine, but we're going to do it anyway. It'll be done the same way. Again, if we have an odd integer, the first one is x, the second one would be x plus 2, and the third one would be x plus 4. Similar to the evens, the odds are 2 apart. So our equations look very similar. 3x plus 6 equals 339. Subtracting 6 from both sides gives me 3x equals 333. And so my x would be 111, x plus 2 would be 113, and x plus 4 would be 115. In question number 4, we have consecutive integers. So if the first one's x, the next one would be x plus 1, and the third one would be x plus 2. These are neither even nor odd, they're just consecutive integers. Solving this, I get 3x plus 3 equals 84. Subtracting 3 from both sides, I get 3x equals 81, so x is 27. X plus 1 would be 28, and x plus 2 would be 29. On question number 5 here, we're going to be simplifying this exponent question, and we have 4x to the negative 3. We move the negative exponent to the denominator, but the 4 isn't to a negative exponent, so it stays put. And so I get 4 over x cubed. On this number 6, we have an exponent on the whole thing, so I'm going to rewrite it with an exponent distributed to the whole thing. So I have 8 to the negative 1, x to the 6th, y2, z to the negative 3, all over negative 4 to the negative 1, x to the negative 4, y to the 6th, z to the 5th. Now, moving all this stuff around, the exponents, my 8 would move to the bottom, become a positive exponent. My x to the 6th would stay put on top because it's positive. The y would stay put. The z would move to the bottom. On the bottom, the negative 4 would move up. Moving changes the exponent, not the base. So if it's a negative 4 on the denominator, it's a negative 4 on the top. Then we're going to move up the x to the 4th. The y to the 6th stays on the bottom. and the z to the 5th stays on the bottom. Putting like terms together, negative 4 over 8 gives me negative 1/2. X to the 6th plus x to the 4th gives me x to the 10th. We have a y in the denominator, a y in the numerator. I'm going to do the subtraction because of the difference rule, and I'm going to have 6 minus 2 gives me 4. I started the subtraction in the bottom. The answer goes in the bottom. Z's, you're going to find the sum of those, which gives me 8. Number 7. We're multiplying here. Negative times negative becomes positive 18. We add our exponents when we multiply, so I get x to the 8th and z to the negative 5. We can't leave it with a negative exponent, so I'm going to rewrite that as 18x to the 8th. The z moves to the denominator.